method dealing with concentrations. And this is just other ways of determining or calculating the concentration of a solution. Very frequently, when you have a very dilute concentration, it might be recorded in parts per million. The reason that we use parts per million, we'll get to it later and show it mathematically, but parts per million is a way of measuring something that has a very small, generally even molar concentration. Okay? You can think about, as a rough estimate, 1 part per million. You can think about 1 part per million as 1 drop in a bathtub full of water. Okay? Now, mathematically, 1 part per million is equal to 1 milligram per liter. If you want to see how that works, what you have to do is you have to look at, and let's just start with 1 milligram per 1 liter. 1 milligram per liter. Well, we can think about this in terms of, and this has got to be in water, and that's all we'll ever be using it in. Or we might talk about air, but then it will just be given to you in parts per million. So 1 milligram per liter. You can think about, okay, mass of 1 liter of water is equal to 1 kilogram. So this is the same as 1 milligram per 1 kilogram. And then we start thinking, okay, well, how many grams are in 1 kilogram? There's 1,000 grams in 1 kilogram. So this is equal then to, well, 1 milligram per 1,000 grams. How many grams are there in how many milligrams are there in 1 gram? Guess what? There's 1,000. So what is 1,000 times 1,000? You punch it in your calculator. Oh, it's 1,000,000. So 1 milligram per liter is equal to 1 milligram per kilogram, is equal to 1 milligram per 1,000 grams, is equal to 1 milligram per 1,000,000 milligrams. Or 1 milligram per million. 1 part per million. And so we don't always have to go through all this metric mathematical rigmarole. What we have to do is just realize that 1 part per million is equal to 1 milligram per liter. Right? So let's kind of take a look at what that looks like and what kinds of questions I might expect of you. Okay. So what mass of chlorine is present in 5 liters of solution if the solution is 6 parts per million of chlorine? Well, here we start and we say, okay, 1 parts per million. Actually, let's do this. We have 6 parts per million given, so let's use that number. 6 parts per million. Oh, I should write it down properly. 6.00 parts per million is equal to, well, if 1 milligram per liter is 1 part per million, then 6 parts per million is the same as 6 milligrams per liter. Okay, lovely. And now we got to look and say, okay, how many liters of solution do we have? We have 5 liters of solution. Okay, so couple ways we could do this. I'll show you a couple of them. We can look and say, okay, so 6 milligrams per liter. And we're going to multiply this by, we want to end up with the mass, so we want to get rid of the liters on the bottom. How many liters? Oh, times 5 liters. Okay. Now this method, we started looking at it yesterday, and I didn't tell you the name of it. It's called unit analysis. And it involves you having to look at the units, and you're doing the math with the numbers, but you're including the units, because if you do the math with the units correctly, it ensures that you're doing the multiplication or division as needed correctly as well. Now here we've got liters on the bottom, we have liters on the top, and we're left with mass, which is in milligrams. And so in this case, it's going to be 30 milligrams of chlorine found in 5 liters of water, given that it's 6 parts per million. Now, if you don't like this, right, we could also look at the concentration and use an older formula that you would have dealt with in like grade 8 or something like that. So concentration is going to be equal to the mass divided by the volume. Okay, so now we're given concentration in parts per million, or milligrams per liter. We're given volume, we need mass. So we'd say, okay, mass then is equal to concentration times volume. This is the second method of doing this. Mass is going to be equal to 6.00 milligrams per liter times 5.0 liters. And if you're thinking this looks like I've done this before, you're absolutely right. I just did this same math up here, just that here I'm using a formula. The first case I was using unit analysis. I looked at my units the first time and realized, okay, I got to multiply them. Here I'm doing the formula and I'm realizing I got to multiply them because I did the math with the algebra bit. And I get my mass of 30 milligrams. Okay. Now we could take this one step further and say, okay, I have 30 milligrams. How many moles is that? What is this concentration in moles per liter? Well, I've got 30 milligrams, which is equal to, and we can change that. We have to divide it by 1,000 to change that into grams. Okay, so we're going to start, we're aiming towards using our, N is, so number of moles is equal to mass divided by molar mass. Okay, so if I've got 30 milligrams of chlorine, now chlorine would be Cl2. Okay, so I've got 2, so my molar mass here is going to be 2 times the molar mass of chlorine, which is 35.45. And my molar mass here is going to then be 70.90 grams per mole. My mass, I need to change this into grams. And I'm going to actually show you a unit analysis method to do that. You can remember that you divide by 1,000, but maybe you can't remember that. And so let's say, okay, we have 30 milligrams. Divide this up. 30 milligrams. We're going to multiply it by some conversion factor. And what do I want to do? Well, I want to have grams on the top, because I put the units I want on the top divided by the units I'm getting rid of on the bottom. Well, we have 1 gram per 1,000 milligrams. Now, how do I do this? I do 30 times 1 and divide by 1,000. 30 times 1, divide by 1,000. Look at this. Milligrams go away. I'm left with grams. And I have 0.030 grams. Plug this into here. Okay, so N now is equal to my mass in grams of 0.030 grams per. And then I've got, okay, 70.90 grams per mole. And you can already see, I hope, that this is going to turn into a very tiny amount of moles. Okay, and so I plug this in to my calculator that I have out. There we go, 0.030 divided by 70.90, and I have 4.2313 and so on times 10 to the negative 4. That's what my calculator spits out. Again, I'm going to find the concentration, so I'm going to just leave this in my calculator as a big number. And I want to look and say, okay, C then is equal to N over V is equal to moles is, there it is, 4.23 times 10 to the negative 4 moles. Divide that by my volume, which all the way back up at the top is 5 liters. That's going to be equal to, so divide that by 5, 8 point, and I look back and see here I have 2 significant digits, so 8.46 would round to 8.5 times 10 to the negative 5 moles per liter. That is 6 parts per million. 6 parts per million, I can wrap my head around that. It's pretty tiny. 6 is a nice number. 8.5 times 10 to the negative 5, a little bit more challenging to wrap my head around. So this is a way you could switch between them. I won't often ask you to do that, but it's good to just get an idea that something like 6 parts per million in moles per liter, really tiny. Okay. All right, so another example here we could look at, label on a bottle of sparkling water lists the dissolved minerals as 440 parts per million. What mass of minerals is present in a 200 milliliter glass of water? Again, I can use my concentration is equal to mass divided by volume that you used all the way back in grade 8, because I remember that my concentration here of 440 parts per million is the same as 440 milligrams per liter. Right, and so what mass of minerals is present in a 200 milliliter glass of water? Well, there's my volume. I have my concentration. Mass is equal to concentration times volume. I have to make sure my volume ends up in liters. 200 milliliters is 0.200 liters. My mass then is equal to 440 milligrams per liter, all divided by, or multiplied by, 0.200 liters. My mass then is equal to, my calculator out, 440 multiplied, by 0.2, and I have 88. That's got to be the 3 significant digits, so 88.0 milligrams. Wonderful. Right. So now what if I gave you, okay, this is the last bit here. What if I gave you concentration in moles per liter? And I told you, what is this, or express this in parts per million? Well, I'm going to have to, first of all, change this into grams per liter. How do I do that? Well, I use my little n is equal to little m over big M formula. I've got n. I would have to tell you what the chemical is for this to work. You can find the molar mass. You have the number of moles. Okay, right? It's whatever number of moles per liter. Figure out the mass. That's going to be the mass in grams. Okay. My next step then, if I want to know parts per million. I need to change from grams per liter into milligrams per liter. Well, how do I do that? I multiply by 1,000. Because there's 1,000 milligrams in 1 gram. Multiply by 1,000, and then I've got it in parts per million. Okay. This takes us to the third method of dealing with solutions. Okay. Now, apparently this didn't quite work out the way it was supposed to. This should not say volume up here, it should say volume on the bottom of the fraction. Okay, so you'll have to change that in your notes booklet. Same thing on the bottom here. Right, this is not an exceptionally uncommon method. Percent by volume means that you're going to take the volume of solute, usually in milliliters, but it doesn't matter as long as you're using the same unit of volume top and bottom. Volume of solute divided by volume of solution, and you're multiplying it by 100 to get a percentage. Vinegar is often measured in this method. Okay, it'll be, you'll see on the bottle of vinegar if you go home, 5% volume V/V. Percent V/V. Okay, and so what you could do there, if you have a certain amount of vinegar, you could figure out exactly how much acetic acid is in there. Okay, or you could figure out how much, what the percentage is if you knew the amount of acetic acid. Okay. Another one, hydrogen peroxide, is measured this way if you have it for like antiseptic use or whatever. It's going to say probably 3% V/V. And what that means is it's 3% of the final solution is going to be actual H2O2 and the rest is water. Okay. Percent by mass, mass of solute divided by volume of solution. Very often, okay, this mass of solute, we'll look at some examples with this a little bit later on and in class. Okay, I'm not going to do a ton with these ones in the video. We will deal with them. The volume ones are much more common. So we'll get to the mass later on. So here, let's take a look at this one here. 10 milliliters of acetic acid is diluted to a total volume of 200 milliliters. What is the percent by volume of acetic acid? So in this case, we have our volume of solute, it's 10 milliliters. We have our volume of solution. Now we have to be careful with this. This 200 milliliters is made up of 10.0 milliliters of acetic acid and 190 milliliters of water. Okay. When we dilute a solid, we sometimes don't think about this, but when we dilute liquids, we definitely have to look at this. So there's 10 milliliters of acetic acid is what I'm trying to get down. And 190 milliliters of water. And I guess I could ask questions, and I'm not going to try to trick you or anything like this, but you could get a question where 10 milliliters of acetic acid is mixed with 190 milliliters of water. What is the percent by volume? Well, you look at the total volume of the solution. So in this case here, concentration is equal to solute volume divided by solvent. No, not by solvent, by solution, as our formula up above says, times 100. And that's going to be equal to 10.0 milliliters of acetic acid divided by 200 milliliters of solution times 100. Okay, and this will be equal to, what we do, 10 divided by 200, 0.05 times 100, and I'm left with 5.00%. And we can manipulate this as required, and I would have to write percent %V/V for volume by volume. Thank you.